This is the screencast for section 2.1, example 2, linear functions and their graphs. This should be very, very old news to you. We're going to review it anyway, and maybe you'll learn some vocabulary along the way. So first of all, polynomial functions of no and low degree. So you already know what a quadratic function is. We've been talking about quadratics as examples in previous sections. A linear function, this book will say ax plus b. A just stands for the leading term. B is your y-intercept. A would be your slope. Constant function is just f of x equals some number. If that number is 0, they call it a zero function. A linear function is a function that graphs as a, wait for it, line, linear function. So that's specifically this example right here that we're going to study in example 2. A slant line is not a horizontal or vertical line. In other words, the slope doesn't equal 0 or undefined. So it's not an x equals, it's not a y equals. Some more terminology we need to understand is the average rate of change is also slope. Remember, f of b stands for the y value or the function's output after I plug in b. And this is the function's output after I plug in a. So this is just like y2 minus y1 over x2 minus x1. So your 2 points that you'd be using here are b comma f of b and a comma f of a. Average rate of change is also m, or rise over run, or the change in y over change in x. That little triangle, or delta y over delta x, they all mean the same thing. Average rate of change, slope, y2 minus y1 over x2 minus x1. Now the initial value of f is the y value when you plug in 0 for x. In other words, the y-intercept, where the graph crosses the y-axis. Initial value where you plug in 0 for x. The constant term is the term in the polynomial with no variable. In other words, when you plug in 0 for x, it's what's left over. It is also the y-intercept. We're going to be looking at some of these problems verbally, algebraically, graphically, and analytically in terms of analyzing a line. So let's start example 2. Let's find an equation of the line of this linear function. So we're going to solve algebraically. The problem says that f of negative 1 equals 2. Well, that means I plugged in negative 1 and I got out 2. The function's value after I input negative 1, its output is 2. The other point, f of 3 equals negative 2, means that after I input 3 into the function, I get out negative 2. So there's my 2 points. I'm going to calculate the average rate of change, or the slope. So negative 2 minus 2 over 3 minus negative 1, negative 4 over positive 4, so that's negative 1. Now I know a lot of you are used to plugging in the x and y coordinate into y equals mx plus b, and that's the only equation you know. But there's an easier way. We don't know what the y-intercept is right now. All we know are a couple of points and the slope. So we can use point-slope form. Point-slope form is y minus y1 equals m times x minus x1. So I have y minus, we're going to pick a point. I only need 1 point, so I'm going to pick the second one. The y-coordinate is 2. My m value is negative 1. Then I have x minus my x1 value, negative 1. So y minus 2 equals negative x plus 1. There is the equation of my line. Now you can distribute the negative sign and add 2 to both sides if you still like y equals mx plus b form. Let's do that just to show you. So this would be y equals negative x minus 1 and then plus 2 from the other side. So y equals negative x plus 1. The y-intercept should be 1. We're going to support this graphically. So in y1, I'm going to put negative x plus 1. Zoom 6. I need to make sure that it passes through both negative 1 comma 2. So let's hit trace negative 1. And I also need to make sure it passes through 3 comma negative 2. So I'm going to hit 3, enter, and I do get the output negative 2. Also graphically, I can see that my slope is negative because my line slopes down to the right. So within my supporting graphically, I've also confirmed numerically because I did each of these inputs and got the correct output. The now try problem number 7 has the same setup as example 2. I have 2 points, and those points are given to me in function notation. So I plugged in -5 and the output was -1. The other input I had was 2 and the output was 4. So I'm going to calculate the slope, which is 5/7. Now I have 2 points and a slope, so I'm going to use point slope form. Y minus, I'm going to use the first point here, which so if y minus -1 equals my slope 5/7 times x minus x1, which is -5. So really that's y plus 1 equals 5/7 x plus 5 in parentheses. Now I could distribute that, but then the fractions are getting kind of messy with this one, so all I'm going to do is subtract 1 from both sides of the equal sign, and now I can plug this into my calculator in its unsimplified form and double check all of my work. So in y equals, I'm going to put 5/7 in parentheses. Then I'm going to put x plus 5, close my parentheses, and then I'm just going to put -1 that came from the y coordinate from the other side of my point slope form. Graph. Now I'm going to make sure that when I plug in -5, I get my output -1. There it is. And I'm also going to make sure that when I plug in, let's see, 2, I get the output 4. So now graphically my slope is positive, which looks good. It's also a slope of 5/7, so it's not too steep. Graphically what I'm seeing makes sense to me, as well as I plugged in some numbers and numerically I did find the right equation for the line.